Working in lab these last few days, a number of students have asked for help in regard to items in the new book. So what I'm going to do here is go through the practice in regard to some items in 7.1, which is Introduction to Probability. Now, in all of these, you need to focus, read carefully, read again, what are they asking, and then reflect on what we've gone over in our flipped classroom video. What is the probability that a card drawn randomly from a standard deck of 52 cards is a black jack? Express your answers as a fraction in lowest terms or a decimal rounded to the nearest millionth. Well, these instructions are for many of these. I won't be reading those again. But I think fractions are probably your best bet. That way you won't have any rounding problems or anything. Now, what is a black jack? Well, probably a quick review of a deck of cards is in order. Now, within a deck of cards, we have 26 that are red and 26 that are black. Now, within the reds, let's go back to, well, let's stay with the blacks. We have spades. Now, a spade looks like this a little bit here, while a club looks a little bit like a three-leaf clover. Now, in the reds, going back to red, we have a heart and we have diamonds. Now, there are 13 hearts, 13 diamonds, there are 13 spades, and 13 clubs, which give you a sample feel of 52. Now, within each suit, and these are called suits, there's a king, a queen, and a jack. These are called face cards, and then they number 10 down to 2, and then there's an ace in each of the suits. So now that we have an understanding of what's in a deck of cards, we're asked, we want to get a black jack. Well, there are 2 suits of blacks, and there would be 2 jacks that are black. So out of a total of 52, you're going to have 2 that meet the qualifications of what they're asking here. So this reduces then to 126, and that is the answer. Now, if I were a student, I would take some notes on this, but again, you're looking for strategy. Now, another type of probability problem you might run into is something like this. Here, a person has this many songs that they can play. They've been categorized into country, rock, rap, jazz, gospel, Latin, and classical. So these are your different categories. And the first thing you might think of, if they didn't give you the 161, is what is your total in your collection? You'd have to add them all up. When you add them all up, they become 161. Now, the probability of what we're looking for here is that the first song played is a rock song. Well, our sample space is 161, and we're looking for rock. Well, rock is 27, and that is our answer. So again, reading it carefully, looking at the information they're giving you, and then fitting it into a reasonable answer. Now, another type of example you're going to get is something like this. So you read it over carefully, and you see you're going to make an ice cream sundae. You have choices of 2 types of ice cream flavors, chocolate, which we'll put here, and vanilla, which we'll put here. So that would be like one category. And then you have 3 choices of sauce. So we'll put those there. And there's hot chocolate, fudge, that will be an H. Butterscotch would be B. And strawberry, which is my favorite, which is an S. And you have 4 types of topping. So in this area, we'll have 4 things. Whipped cream for a W, one of my favorites also. Fruit, nuts, and a rainbow sprinkles, which we'll call R. Now, fortunately, we have all different letters. Now, what they're asking is, what is your sample space? Now here, this is just tedious. And how many are you going to get all together? Well, you have 2 times 3 is 6. 6 times 4, you're going to end up with 24 combinations. Again, where the difficulty level is low, it's just tedious. So on each of your combinations, you're going to have one of these, one of these, and one of these. And every time you change one thing, it makes a different combination. And they want you to list them. So you can see that this is just tedious. Chances are some are fewer. I've seen some where there's just 12 things that you have to list. And if you get one letter wrong, of course, they're going to count it wrong. So develop a system. And a suggestion might be you start with the C. So C, that would be this one. The H, that would be this one. And then the W. Then you put a comma. Then your C. Keep the H, let's say. Then you're going to do the F. And you're going to write them out and then just continue. And again, this is just part of the answer here, because if you slide this along, you see there's a list of 24 things. So this is just to dig in and grind it out. type of thing, and that would be one of your questions. This is not going to be on the test, but it is on the Certify. Now, on this next one, again, you have to read it carefully. I'll read it along with you. Find the probability of obtaining exactly 9 heads when flipping 10 coins. So for something like this, you're going to have to find out what is your sample space. Well, some background on this is that a coin has a heads and a tails. So there's a possibility of 2, but you're going to have 10 coins. So that would be your possibility of 2 raised to the 10th power. So our sample space here is going to be 2 to the 10th power. Now, what are we looking for? Well, I'm going to draw this out and do it offline here for a moment. So what I've done is I've thrown 10 coins, and this one is tails. But now I have 9 heads. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have too many. So I don't want to have that many. I want to just have 9. Okay. Now we have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Very good. All right. So for illustrative purposes, this would be one possibility, right? Now, I can move this tails to this position and the heads to that position. And as I go through it, that T can be in 10 different positions, right? So what is the possibility of having 9 heads and 1 tail? Well, there are 10 possibilities. And then that is your answer. Now, if you put that into your calculator, you get this, but it's rounded off to the millionth place because there is a, this is actually a 5 and this is a 6 or something over here, and it gets rounded off. Now, if you put this in there, they're going to count it wrong because you didn't simplify. So what would be the fraction? Let me show you that. Well, 10 is 10, and 2 to the 10th power is 1024. So you could take a 2 out of each one of these, and this would be the fractional way of expressing. And if you put that in your calculator and round it off to the nearest millionth, you get that. Again, often I would think if you're stuck at home on something or any of these problems, you're going to open up the tutor. Because in our flipped classroom video, we only covered the general background. Now you are doing specifics. Now in this next example, we're looking at a standard die. Remember, this has 6 sides, and the sample space is 1, 2, 3, 4, 5, 6. Now, find the probability that the number rolled is less than 4. Well, there's your standard field, and there's 6 items, and that is going to be less than 4. We have 3. So 3 out of 6 is 1 out of 2. Now they're saying this is medium, but to me this is one of the easier ones. Now in this next example, we're getting to some material that is sort of challenging. This is of medium difficulty. In a recent survey, it said that 93 full-time employees out of 400 did not use all their vacation days last year. Well, that's information. However, 118 of those studied, that would be out of the 400, desired more vacation time. All right. Now, I should mention that this 93 here is something they stuck in there that's not actually part of our probability here. So we're going to disregard this. All right, let's go on. Based on this sample of full-time employees, if chosen at random, what is the probability that he or she is content with the vacation allowance? So as we go to the analysis of what we need to do, we have our total of 400. We have 118 express desire for more vacation time. So we're going to find the complement of this, in a sense, by subtracting the 118 from the 400, which gives us now 282, which are those who are content, and this would be out of 400. So if we take a 2 out of there, we get 141, and a 2 out of there, we get 200, which is our probability of selecting someone who is content. All right, again, they threw this in as background, but it's not really part of this. If they had left it out, it would have been a lot easier, but note when you read something like this, you're dealing with what is there. Now, for this one, here we want to read each of these statements and then determine, and sometimes it could be more than one, which are empirical. Now, a little background on empirical is, if I have a styrofoam cup and I toss that cup 100 times, sometimes it will land like this. Sometimes it will land on its side, and sometimes it will land on its bottom. These are the three kinds of things. So as you say, what is the probability of landing on its bottom, on its side, on its top? You're collecting data. This is empirical data. Now, if you have a set of dice or playing cards, and you mathematically figure out what's the probability, then that is classical, because you're not just randomly getting and collecting data and using that as a sample. So we went over this pretty well, I think, in our flipped classroom video, but then it's a matter of analysis to pick out which ones they are. And you can pause and read these. And again, she picked Dominique wants to know percentages of red cards in a large pile of playing cards. So again, this is random data of a pile. You're not saying you know precisely there's 52 cards in the deck. So read the others. The others are classical. All right, we'll go on. Almost finished. All right, this is our last question on this session. And what we're looking at is a military clock that at just after midnight, it goes 00:00, and then it starts 00:01, and then 2, 3, and then it gets 60, and it makes an hour, and then it goes through the day, so that as it approaches midnight, it's going to read 24:00, and then it reverts back to this. So that's how military clocks work. Now, they're asking us here, find the probability that the number made up of the first 2 digits is less than 25. Well, the highest it goes to is 24, so that it's going to be less than 25 is always. So what is always in probability? Well, that's 1. That's the whole. Now, if they were to ask that the military clock would be more than 25 in the first 2 digits, well, it only goes up to 24. So it's never going to be 25. So that probability would be 0. Now, generally, when we speak of probability, we're thinking of things between 0, that is not happening, and 1, the whole, in which it's always happening. Okay, well, hopefully this is helpful. Good luck on yours. And I've given some extra time actually for this.